Hello again. So we finally reached the final section of our notebook, a function in a function. So you already know that you can use a function inside a function. Maybe you didn't think about it, but you haven't thought about it when you were doing so. But if you have a look at examples before, for instance, you have been using a print function inside a function. So even in our notebook, if we go back somewhere like here, we can see that we have a function calling, which inside its body has a call to some other function, and in this case, it's a function print. And it's not like this that print is some special function which you can use inside a function. You can use any function inside some other function. Moreover, you can use the function you are creating inside the body of a function. And this might seem scary or counterintuitive at the beginning, but there is a concept like this, and it's called recursion. And as always, we will go ahead and have a look at an example. So this time what we are trying to achieve is to sum all numbers up to some number. So for instance, if we want to sum all numbers up until up to 4, then we would have to sum 1 plus 2 plus 3 plus 4, so we would get 10. And of course, we could do it with for instance, loops. For instance, using a while loop, and there is an example of how to do it here. But right now we want to learn recursion. And why do we want to learn recursion? Well, because often problems like this, which are simple, they are really simple to write using for loops or while loops. But when problems get complicated, it's often the case, I personally find it much more easier to solve these problems using recursion. Because how does recursion work? Well, we can write the same function in the following manner. So here, when we were creating this function, we decided that things work like this. We want to sum the numbers. At the beginning, our result is 0, and then we increase the number 1 by 1, and we increase the numbers 1 by 1 and get the result. Actually, I can see that here in the text there is I plus 1 missing. Here in this line here there should be I equals I plus 1. So this example should be corrected. It will be corrected in your materials for sure. But here what we do, like when you think about the algorithm, is we start at 0, then add 1, increase 1 to 2, add 2, increase 2 to 3, add 3, increase 3 to 4, and add 4. When we start thinking about this problem recursively, we can look at it in a different way. So basically, the answer to this computation, what is the result of summing all of the numbers up to 4? Well, the answer is 4 plus summing all of the numbers up to 3. So this is the recursive way of thinking about this problem. And you can also tell Python to do things in this way. And this is how you do it. So first of all, you have two cases. One is a general case. So basically, if you have any number different than 1, then your answer for the question you are given, so for instance, what is the sum of all numbers up to 10, then your answer is 10 plus sum of all of the numbers up to 9. And this is your final answer. If you know what is the sum of all of the numbers up to 9, then you can just add 10 and get the result. So this is a general case. General case works like this, that you just give Python a receipt how it can get the answer. You don't give him the answer explicitly, you just give him the instructions how to do it. Another case is a base case, and this is a case where you by default know the answer. So in our example, this would be, for instance, for 1. So what is the sum of all of the numbers up to 1? Well, it's 1, because it's just 1, and you don't have to sum anything else, because you start where you finish where you started. And this is exactly how you do it also in Python. So what you do, you specify, and note that in general you can have more than one base cases. You can also have some scenarios when general cases like switches to some different scenarios depending on what you see. But here we have just one general case and one base case. So basically, as we discussed just a minute ago, if a number is bigger than 1, then we want Python to return a general case. So we want for Python to perform the general instruction. So what is the answer for our function? What should our function return when the number is bigger than 1? Well, it should return this number plus sum all numbers computed on a number which is 1 smaller. So for instance, for 10, if 10 is bigger than 1, so this code is executed. So we ask Python to return 10 plus sum all numbers from 9. And if you already know what is the answer for sum all numbers of 9, then Python just inputs this here. If you don't know this value, then Python goes into this function and he sees again this code. And 9 is bigger than 1, so he again goes here, and 9 plus sum all numbers 8, and Python has to determine what is sum of all numbers up to 8. And so on and so on and so on. And at some point, Python reaches the argument here is 1. So Python tries to execute sum all numbers 1. What happens then? This condition is not met, so Python executes this code, and Python knows that the result of this function is 1. So now Python knows that sum all numbers 1 is equal to 1. So he goes back one step above, and then he can answer the question what was the the answer for the call sum all numbers 2, because sum all numbers 2 was 2 plus sum all numbers 1, and Python already knows that sum all numbers 1 is 1. So 2 plus 1 is 3. We have this answer. So Python right now knows what is the answer to sum all numbers 2 of argument 2 with argument 2. So now he can answer the question what is sum all numbers with argument 3. Well, it's 3 plus sum all numbers with argument 2, and this was also 3, so 3 plus 3 equals 6, and so on and so on. So this is, and then it goes back up until 10 or some other argument we have provided. So let's have a look how it works in practice. Let's run this code. So we have a script here with this example. So let's see that it works. Let's run this script, Python 3 sum all. So as we can see, sum all numbers up until 4 equals to 10. This is correct. 1 plus 2, 3, plus 3, 6, plus 4, 10. If I increase to 5, I should get 15. If I increase to 6, I should get 6 more, so 21, and so on and so on. And this is just like I was increasing here. Similarly, the Python solves this problem, because this is how we told him to solve this problem. Just add the number. So right now when I'm increasing to 7, and I want to figure out what is the answer in my head. Since I know what is the sum all numbers 6, it's 21. I know that if I increase here by 7, then this should be increased by 7, so my answer should be 28. And this is also how Python solves it, but if he does not yet know what is the answer from the sum all numbers 6, 5, and so on, he first tries to solve this. If he cannot solve this, he tries to solve this smaller problem, and then at some point it reaches the problem which is so small. In this case, it's when we call sum all numbers 1, that he knows the answer to this problem, and then he goes back. Okay, so because I know the answer for this problem, I go up and I know the answer for the bigger problem. I know the answer for this bigger problem. I know the answer for the more bigger the even bigger problem, and so on and so on and so on. And he goes back until the final result which he was asked to, the final problem which he was asked to solve. So this is the recursion. I encourage you to read through this notebook. Don't try to rely only on the video, because you have to kind of go through it yourself. It's explained in detail in the text, and in the next video we will talk about some other situations where you can use a function inside another function. So this summarizes recursion, and hopefully you enjoyed this, and see you in the next video.